So we have been talking about the periodic table in terms of the areas. So we know that there are metals and nonmetals, and we know properties of those. And then we've talked about specific groups like alkali earth, and halogens and noble gases, and we started hopefully making some connections there as to why elements belong in a certain group. Now what we want to look at are 4 other trends that occur in the periodic table. This video is only going to cover one of those trends. So in your notebook, what you want to do is highlight this section as periodic trends, and then just know that there are going to be 4 of them, okay? So as you go, you may need to pause this video to write some things down, but I'm not going to give you pauses where I stop talking. I'm just going to keep talking. So do not be afraid to pause the video to write some things down. Our first trend that we are going to look at is called atomic radii. And first of all, what we need is a definition for atomic radii, okay? And it's essentially right there for you, but it's defined as half the distance between the nuclei of identical atoms, okay? So right here, what we have are 2 identical chlorine atoms, okay? And right here, these points, okay, are marking the center or where the nucleus is of those. Now, in order to measure the distance between these, okay, we don't know where the outside edges of electrons are, okay? So we actually have to measure the distance that occurs between the nuclei, because those are actually in fixed positions. Remember, electrons are located in electron clouds, and we don't know where the outside exactly is of those clouds. So if I have 2 electron clouds, I have to measure the nuclei between them, because that's something that's fixed, and then I can take half of that distance. Okay? Now, what we want to look at are, okay, what are some of the trends for atomic radius, okay? And actually one of the easy ways to do this is to actually draw Bohr models, okay? So we are going to draw some Bohr models, okay, of atoms. And I'm going to look at 2 different trends, okay? We're going to look at group trends, and then we're going to look at period trends later, okay? So we're not going to look at periods right now. So we're going to look at group trends. So what happens as you go down a group with the size of atoms? And a Bohr model actually is a good way to look at this, because if I draw a Bohr model for lithium, I have the nucleus, and it has 2 energy levels. Okay? If I draw sodium, it has a nucleus and 3 energy levels. Okay? I'm going to draw 2 more here. I'm going to draw potassium. It has a nucleus and 4 energy levels. Okay, and then let's see if I can squeeze this one in here. I am going to draw rubidium, which has 5 energy levels. 1, 2, 3, 4, 5. Okay, now, just in my drawings, which I apologize for, just in looking at these Bohr models, what actually happens to the size of these atoms as you go down the group? And if you look at just the Bohr model, okay, the trend as you go down a group is that you increase in size. That's the trend. So the trend for groups is that atomic size increases down a group. And this would be for all groups in the periodic table. That should be the trend. So it shouldn't matter if I look at group 2, which would be beryllium, magnesium, calcium, and strontium. Okay, the atomic size should still increase down that group. Now, one of the big things that I am going to be pushing is, what's the reason? Okay, and essentially, if you look at these, okay, the reason should actually be very clear. As you go down a group, you add energy levels. So that's going to make the atom bigger. Okay, so that is my reason. As you go down a group, you increase energy levels. And that, by default, makes these atoms bigger. Okay? So, there's our first trend in our periodic table, is that as we go down a group, okay, so I have my periodic table here, as we go down the group, we're going to increase in size. Okay? Now, kind of highlighted the next one. But now we're going to look at the period trend. Okay? And something happens differently as you go across a period. Okay? So, for convenience sake, I'm just going to choose period 2. Okay? And in period 2, we have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Nitrogen, oxygen, fluorine, and neon. Okay? So, first of all, in period 2, one of the things that you have to realize is that all of these have only have 2 energy levels. Okay? So your first instinct would be, well, if they all have 2 energy levels, then shouldn't they all be the same size? Okay? But that's actually not the case. Okay? Because one of the things that happens as you go across these is we tend to start adding more electrons. So lithium has 1 electron, beryllium has 2 electrons, boron 3, carbon 4, nitrogen 5, oxygen 6, fluorine, I'm going to just put dots, 7 because I got really small here, and neon 8. Okay, so apologize for my dots at the end, but they're still electrons. So one of the things that happens is as you go starting from here across, because you get more electrons, you get more attraction. So the increase in electrons causes an increase in attraction between the nucleus and outer electrons. Okay? Because the other thing that I didn't really say here was there's something else that's increasing. Okay? The other thing that's increasing is there are 3 protons here, there are 4 protons here, 5 protons, 6 protons, 7 protons, 8 protons, 9 protons, and 10 protons. So the number of protons in the nucleus is also increasing. So because protons and electrons attract each other, okay, as you go across the period, there is going to be a very strong attraction between the electrons and protons. Whereas over here, there's a weak attraction. Okay? Now, you are probably saying, so what? Well, if you consider, okay, that these are going to be attracting each other, okay, what's going to happen is this right here, okay, this here is my outer ring. I didn't put the inner ring. So this is positively charged, and I have electrons here. Well, there's going to be a slight attraction between this outer electron up here, okay, and this nucleus. There's going to be an attraction that's going to occur between those. That attraction is going to take this energy level and pull it in a little bit. Okay? But now, if I start adding more electrons, then our pull towards that nucleus becomes even stronger. So then what happens here is this gets even smaller. Okay? And I know my electrons are moving here, but if you start adding more electrons to this, then you are going to get more of a pull towards the center of that nucleus, and this is going to get even smaller. Okay? So overall, what's happening here is the atom itself, as it goes across, okay, goes across the period, the atom goes from really large to really small. And you can see that in this diagram right here. Okay? So this is showing the main group elements. Okay? And as you look, lithium starts out big, but then as we go across here, neon gets smaller. And that happens in every one of these. We start big. The trend is to get smaller. Look at this row. Start big, get smaller. Look at this row. Start big, get smaller. Okay? So the trend, and that's what we look at, is to decrease in size as you go across the period. Okay? So we want to write that down. So the period trend, and we're still on atomic radius, is to decrease in size across the period. Okay? So that is the atomic radius trend. And again, we want a reason, and I'm always going to ask you for a reason, and that is because there is greater attraction between electrons and protons as you move across. Okay? So, I'm going to show you one more picture then, well, a full periodic table. So this is a full periodic table. So in this particular periodic table, we have included the D block elements as well. And you can see that definitely here, trend, we are getting smaller. Definitely here, trend, we are getting smaller. Now, even across the D block, okay, there's not a whole lot of change through here, okay? They don't actually change that much. But the trend is that they get smaller, okay? So that is the period trend, the period trend. But then also one of the things we want to do is look back at what we just talked about. What's the group trend? What's happening in this group? In this group, we are increasing as we go down. What's happening in this group? We are increasing as we go down. This group, we are increasing as we go down. Even the halogens, noble gases, increase as we go down. Okay? Now, what's going on here? Very little increasing going on here. Okay? But it is. We don't have real numbers here, but we could throw some real numbers out there. Okay, one last thing before we go. So you're going to make a summary periodic table. Okay, now, in this summary periodic table, what you want to do, okay, and you maybe want to watch me make this first, is you're going to sketch out a good rough sketch of a periodic table. Okay, so this is my rough periodic table. These are groups 1 and 2, 13 through 18, 3 through 12 in there. Okay, now just looking ahead, you are going to write 4 different things down this side, which is why I shifted my periodic table over a little bit, and then you're going to write 4 summaries down here, okay? So, make this periodic table without the red lines, please. Okay? And what we're going to do is we're going to put atomic radius here, and we're going to put increases down. And then we're going to put atomic radius here, and we're going to put decreases as we go across. Okay? Now, again, we're going to add more to this. So this is going to be a summary periodic table that we're going to come back to. So that is our first trend.